So we're about to start chapter 5, but before we do, we need to go over the elements that you guys need to know for our elements quiz next week. Okay, so on the front of your note packet is a study sheet. I just stapled it there to begin with so that you had everything together, but if you, when you're studying, would like to take that part from your notes, that's completely fine. Okay, so we're not going to go in order of the paper. But the reason why we're not going to do that is because I'm going to tell you some ways to remember, okay? So the first elements that we're going to talk about are symbols with one letter. And so it's the first letter of the word capitalized. Okay, so take a minute to fill those in and find them on your paper. The next are letters, or symbols, with two letters. And these are the first and the second letter of the name. So the first letter is always capitalized and the second letter is always lowercase. You have to make a distinction, okay, when you do that, and that's going to help us out later. So go ahead and find these in. Make sure you're writing them with the correct element. Don't get your study sheet mixed up. The next list are symbols with two letters, but it's the first and the third letter of the name. Like, for example, arsenic. We already have argon as AR, so we can't have two ARs on the periodic table, otherwise we don't know which one we're talking about. So arsenic is AS instead. Also, there's no element that's CH. Chlorine and chromium are both following this rule of the first and third letter. Magnesium and manganese are the same way. But that's okay. And the last list are symbols that don't match up with the name, and that's because they are based on the Latin word for the element from a very long time ago. Okay, so I'm just going to go through this list and say them out loud for you so that you know what they sound like. I would also write down, I wrote on the right side of the list the Latin-based name. That might be extra credit on our quiz next week, so you might want to write that down. But it is very helpful to have that with you when you're studying. So antimony is SB, and that stands for stibium. Copper is Cu, which stands for cuprum. Gold is Au for aurum. Iron is Fe for ferrum. Lead is Pb for plumbum. Mercury is Hg for hydrogyrum. Potassium is K for calcium. Silver is Ag for argentium. Sodium is Na for natrium. Tin is Sn for stannum. And tungsten is W for wolfram. Okay, so those are all the symbols that we have to know. Let's go ahead and start our notes. We are going to be focusing on the electrons this time because when Rutherford came up with his model of the atom, he was only focusing on the nucleus, and he didn't know how to explain the negatively charged electrons and where they occupy the electron cloud outside of the nucleus. He just wasn't focusing on it. So the new focus was on the electron cloud surrounding the nucleus and its electrons, and the electrons are super important to chemistry. So, as early as 1900, scientists considered light to act as a wave. So some vocab words about waves. The amplitude of a wave is the wave's height from zero to crest. The wavelength, which is symbolized by an upside down Y, it's the Greek letter lambda, is the distance between the crests. Frequency stands for the Greek letter nu, which is a V, is the number of waves cycles to pass a given point per unit of time. So just down here in the bottom right, if you have a short wavelength, that means that the waves will be very close together. And when you have a shorter wavelength, you have a higher frequency. But if you have a longer wavelength, so the waves are more spread out, then you have a low frequency. So now we need to look at our electromagnetic radiation spectrum. It's the nice rainbow paper that you should have picked up. This helps us to look at the entire frequency range of electromagnetic radiation, and there's many different kinds. So let's just take a look. This is the one that you guys have, where the rainbow at the bottom is just moving out the visible light, which is in this tiny little spot right here. This is actually at 1 times 10 to this -6 meters, so that's pretty small. As you notice, the wavelength gets shorter from left to right because a negative exponent, remember, is a tiny decimal. So, and the picture here kind of shows you how it gets to be a shorter wavelength as we go. Well, if it gets a shorter wavelength from left to right on the paper, then that means that we're going to have a higher frequency from left to right, which is symbolized down here. Okay? This paper will help you to answer 2 of the questions on the homework wave equation practice, so you need to keep this handy. Alright? So, some units for the waves. Wavelength can be in meters or nanometers, and M for nanometers. And frequency can be in hertz, which is named after a scientist, Hz, or cycles per second. But I tend to use hertz, and your homework will tend to have hertz on it, so just remember hertz. Okay? So remember, the longer the wavelength, the shorter the frequency. The shorter the wavelength, the higher the frequency. And then this is also saying energy, which we'll talk about in a little bit. So the relationship between the frequency and the wavelength has this speed of light equation, where C equals the lambda wavelength times the frequency, the V. Okay? The speed of light, for our purposes this year, we're going to say that the speed of light is 3.0 times 10 to the 8th meters per second. Okay? So make sure you write that down because you're going to need that in your calculations. Okay? And then remember the units. If we're using this equation, wavelength must be in meters. So if it's not in meters, we have to convert it to meters. And frequency is in hertz. And we know that we can use this equation because all forms of EMR, electromagnetic radiation, travel at the speed of light no matter what medium or lack of medium, meaning like a vacuum, it travels through. So if it's flying through air, if it's flying through space, if it's flying through a different type of gas, it all travels at the same speed. And so then we can use this equation for us. So let's go ahead and try to use it. The wavelength of red light, so if you ever see a red light, is 700 nanometers. What is its frequency? Okay, well, we are going to be using our speed of light equation. The C equals lambda times V. Okay, we need to know what we're going to plug in and what are we trying to find. Well, it says in the problem the wavelength is 700 nanometers. So the 700 nanometers is our wavelength, our lambda symbol, and we want to know the frequency. So I would make sure that you are like circling these things, being an active participant in this example, because this is what you need to do to help you on the homework, okay? So we're going to plug in our our wavelength into our equation to get frequency. And remember that C, the speed of light, is 3.0 times 10 to the 8th meters per second. Okay, so the last thing we have to do, we cannot put 700 nanometers in our problem because the speed of light equation needs it to be in meters, okay? So we need to first convert that before we go. So we're going to do some dimensional analysis, put what we know over 1. So we know that we have 700 nanometers. And we want to use that conversion factor in the parentheses to get rid of nanometers and be left with meters. And please note, it's a typo in your notes. It's supposed to be a positive 9 exponent. It says negative 9 in your homework, and that is incorrect. So We're going to put 1 meter on top, because that's what we want, and we want to cancel the nanometers, so we're going to put 1 times 10 to the 9 nanometers in the denominator, and then cancel them out. So then we can divide, and when you divide, it comes out, on my calculator at least, as like 0.00000, a bunch of zeros, and 7. Well, to make life easier, let's keep it in scientific notation, and it's going to be 7 times 10 to the negative 7 meters. Okay? So that is our new wavelength, the new lambda. Now we can plug and chug to find frequency. So we have 3.0 times 10 to the 8 equals our wavelength of 7 times 10 to the negative 7 times v. Well, how are we going to get v by itself? We're going to divide both sides by our wavelength. So we're going to divide both sides by 7 times 10 to the negative 7. So that on this side they cancel, and we're left with v, our frequency. And now we can plug that into the calculator. So how do we do that? Hopefully you have one in your hands so you can practice. Ready? Type in 3.0 EE8 divided by 7 EE negative 7 equals, and you should get 4.29 times 10 to the 14th. Our unit on frequency is the Hz, the hertz. And last but not least, we have to round to significant figures, which in this problem, we have 1 sig fig from our wavelength. So we would just round this to 4 times 10 to the 14th hertz. Alrighty, so I'm going to stop you here. This will all be all that we do for today. On the homework titled Wave Equation Practice, I want you guys to try numbers 1, 2, 3, and 4. So 1 through 4. You're just going to be using the speed of light equation, c equals lambda times v. Numbers 2 and 4, you need to look at your EMR spectrum, the rainbow handout sheet, okay? And that will help you to determine the answer for those two. Alright, I will talk to you later. You should have some class time to try and work on this.